Hello everyone, this is the video for lesson 2.3b, modeling with quadratic functions. We have two learning targets for this lesson. The first one is you can find the average rate of change in a nonlinear function, in this case a quadratic function. And in the other one, you will be using technology to find a quadratic model for a set of data. So let's take a second and talk about average rate of change. Now, average rate of change is something that you found before, but typically we call it slope. So average rate of change is slope, and you use 2 points. The only reason why we don't use slope and instead use average rate of change is because we are dealing with a non-linear function. We're dealing with a parabola. It is a curve. And the average rate of change can be different depending on what 2 points that you use. So if you look at this one right here, this is a linear function. It is going to be consistent regardless of what 2 points that you use. So if you look here, you're going to count down 1, 2, 3, 4, and then over 1, 2, 3, 4, 5. So that would be down 4, right 5. It doesn't matter what 2 points you use on this graph, it is going to be negative 4 over 5 regardless. So that's why we call it slope over here. And it's going to be negative because it has that decreasing left to right pattern. And you can see the very familiar slope formula that we've used before. That is also on your formula sheet, so you don't have to have it memorized. The average rate of change formula, if you look in your textbook, looks different. It's the same, except for they use function notation. So instead of them saying they want you to use y sub 2, they're saying you should plug in x to find the y formula. Okay, I promise you it's the same. So if you look on your formula sheet, you can use this one every time. Let's go ahead and talk about the average rate of change on a quadratic function. So when you start working with average rate of change problems, you need to understand that average rate of change is the slope. You need 2 points to find the slope or the average rate of change. So I'm going to give you 3 different examples. Please don't copy it down on your notes because I'm going to erase it and then give you a different example. So I'm going to say that I've got 2 points. Let's let one of them be here and then the next one over here. If I connect these 2 points, I get this lovely purple line right here. Now, if I read that line from left to right, you can see that it is decreasing. So that is going to give you a negative average rate of change. It basically says between this first point here and the second point here, I am going to decrease on average a certain amount. Okay, so that's one example. Let's say that I pick this point here and this point right here, and I'm going to connect these dots. Okay, so reading this left to right, you see how I'm increasing? That's going to give me a positive average rate of change. So between this first point over here on the left to the end point over here on the right, I have so much increase over that interval right there. Okay, last example. Let's say that I have a point here and a point here. 2 points on the graph. If I connect these points, notice how I have a perfectly horizontal flat line. That actually is a 0 average rate of change because I don't have any rise. There's no difference in vertical, and I've got all the horizontals distant. So it's basically, if you found the slope between these 2 points, you're going to get 0. There's no change. So over this point right here, starting here and here, the average would be no change. Now, clearly you've got a decrease, but then you got an increase. But overall, average-wise, it's going to be a 0 rate of change. Okay, so this first part right here is going to be like a review of some of the things that we've done in the past. We've got a meteorologist. He creates a parabola. He's predicting the temperature tomorrow, where X is the number of hours after midnight and Y is the temperature in degrees Celsius. If this seems familiar to you, it should, because we actually wrote the equation for this graph in lesson 2.3a. So what I did is I copied this formula right here to your notes. This is what we did on your notes the day before. And your vertex is going to be 14, negative 10. So I'm just going to give you a hint. Let's go ahead and label the axis of symmetry and the vertex on the graph. So axis of symmetry, and we did this the other day, but it is also helpful for today. So x is equal to 14 is my axis of symmetry, and my vertex is right here. Vertex is positive 14, negative 10. Now the reason why that's important is we are going to find the interval where it is decreasing and when it is increasing. So I'm going to use colors. I like to use blue for my decreasing, and then I'm going to use green for my increasing. Remember, you need to read left to right. So if I start over here on the left, you see how it is decreasing, maybe not at the same rate, and then eventually it kind of slows down and then it stops decreasing right here. So I'm going to highlight right here up to the vertex there. So that is my decreasing section. Now my increasing section starts at the vertex and then it kind of stops right here at the end point. So it's a little bit shorter, but that is definitely going to be increasing. Now I'm not going to be using negative and positive infinity because this domain is limited. It does not have arrows on it. So it actually has a leftmost point, and the leftmost point is 0. Do not use 10 because that is, or 9.6, because that's the y value. When you do your intervals, make sure that you're using your x value that represents left to right. So the rightmost decreasing point is 14. That is your vertex. So your axis of symmetry, what it does is it splits it into the two parts, decreasing and increasing. So this is the leftmost point, and this is the rightmost point. Let's do the same thing for increasing. So it starts back increasing at 14, and then it stops at 24. Don't use positive infinity because it doesn't have an arrow on it. It doesn't keep going. So the leftmost point that's increasing is 14, and the rightmost point is 24. Now I'm not putting brackets on there because it's not included. The vertex is kind of changing its mind. It's neutral, and so are the endpoints. Now that we found our increasing and our decreasing intervals, we can go ahead and answer our average rate of change question. So it says, find the average rate of change in temperature over the interval in which it is decreasing. Okay, well, I've already found that interval where it's decreasing. So it's decreasing from 0 to 14. Okay, now remember, your interval is your x-coordinate. It's your leftmost to your rightmost point. So those are actually x-coordinates. Now to find the average rate of change, you have to find the y-coordinates that go with each x-coordinate. All right, so we're going to put 0 here. That's my left x. And then my right x is 14. And all you have to do is just look on the graph for when x is 0 and when x is 14. So when is x 0? We have y is 9.6. And when is x 14? It's negative 10. So I'm going to use 0, 9.6, and 14, negative 10. All right, so we are finding the average rate of change over the decreasing interval. So you start with your left interval, and you find your y-coordinate, and then your rightmost point, find that y-coordinate, and we're going to plug those in to your slope formula. So remember, your slope formula is y2 minus y1 over x2 minus x1. And if you want to highlight, these are your y's. And I'll use purple for my x's. So it'd be negative 10 minus 9.6. Be really careful if you're subtracting a negative number. Make sure you change it to plus or positive. And then your x-coordinates would be 14 minus 0. Okay, you wind up with negative 19.6 on the top, divided by 14, which is negative 1.4. And you can go straight from here to here if you're using your calculator. So what you need to do is you need to make sure that that makes sense, okay? So if you are finding the average rate of change over a decreasing interval, then yes, it makes sense for it to be negative. So decreasing means you're going to have a negative slope. So that part makes sense. How do we actually interpret this though? Okay, now I want you to think it's your change in y over your change in x. So look at your graph. We're going to change in temperature per hour after midnight. So average rate of change is slope. So it'll be the temperature, the degrees in Celsius per hour change, okay? So since it's negative, we would lose degrees Celsius. So we're going to say on average, because it's average rate of change, we're going to say the temperature. We're going to say it decreases because it's negative, and it's going to decrease 1.4 degrees Celsius per hour past midnight. Okay, now example number 2 is not out of your textbook. It looks like something that's very similar to a benchmark question or your end of course questions, and we've got to get familiar with those. This time they don't give you a graph, they give you an equation. So what that does is it increases the difficulty of the problem, but it's okay, we can handle it. Pretty much the same steps, except for you have to do a little extra work. So they give you an equation, and then it tells you have a function over the interval from 0 to 5. So what I'm going to do is I'm going to write that interval in interval notation, because currently it is an inequality notation. And I should use brackets because it has equal to on it. And then it says find the coordinates using h of x. So just like you did last time, 0 is going to be your leftmost point. And then 5 is going to be your rightmost point. And they are x coordinates. So for you to be able to find the y coordinate, you can't look at the graph. You have to plug it into the formula. So we're going to plug in 0 the first time. Okay, so if I type in 0 for all of my x's here, I wind up with, you can just type it in your calculator, you wind up with 20. So if x is 0, that means that your y coordinate is 20. So I'm going to write it over here. Then I'm going to plug in 5. So h of 5. Wherever there is an x, you're going to replace it with a 5. And then on your calculator, type all of this stuff in on the right, and you wind up with 35, which means your point is 535. So it gives you the same thing that you would have if you were just looking at a graph. Okay, remember, here's your y coordinates. Here are your x coordinates. So we're going to substitute this into the slope formula. I'm going to write it down just for your notes. Okay, we're going to take the y coordinates, that's 35 minus 20, and then we're going to do 5 minus 0, which gives you 15 over 5, or 3. So on average, between where x is 0 up to where x is 5, the average change is going to be up 3 over 1. All right, so now we're in the technology part of your lesson. We are going to find quadratic model. aka using quadratic regression using Desmos. So go ahead and access Desmos. Make sure you're using the Tennessee version of it. And we're going to input this table right here, this table of values. All of your steps are right here, but on the video, I'm going to go ahead and just show you how to get through all of that and use steps 1 through 4. You may have a typo on your notes. Just kind of double check and make sure that your code is correct and it's got the little tilde here and the little square on here. Okay, so I've already entered the information from the table into my Desmos. And if you don't remember how to get to your table, just click on your little plus sign and then click on table. Do a quick double check and make sure you have an X1 and a Y1. It has to match your code. So on line 2, but first, we need to look at our data. So if you want to look at your data, I want you to click on this little zoom fit here. You may have to do it a couple of times. I can see my points. It's not perfect, but it's pretty darn close to an upside down parabola here. I'm gonna scoot it just a little bit. I want to see right here where the origin is, and I'll tell you why in a second. Okay, on line 2, we're gonna type in y equals ax squared plus bx plus c. That is standard form. So I see that it has that parabolic pattern to it. I'm going to type in standard form. Notice how it doesn't do anything for me. Remember when you were doing the other line of best fit, you have to put ones next to your variable. So whenever you have a y or an x, you have to put a 1 next to it. So I'm going to go back in. I'm going to put 1. And then next to the x, okay, make sure it's not in front of the 2. Make sure it's just to the right of the x. Put a 1. And you have another one here. Put a 1. It's still not doing anything. Remember, regression equations or line of best fit is only an estimate. You cannot have it equal. So get rid of the equal sign, and then you're going to hit Shift tilde. And as soon as you do that, you're going to have that estimated parabolic graph pop up, and it should get pretty close to the points. It may even touch a couple of the points, but it needs to be close. Remember, it's an estimate. So the things that you need to notice are squared. We don't have a correlation coefficient if it's quadratic. That's called the coefficient of determination. Don't worry about r squared, okay? As long as you can see that it's close to your points, then it is definitely a usable model. What you need to do is you need to look at A, B, and C right here. A, B, and C. And we're going to jot that down on your notes, and then I'm going to tell you how to use that. Okay, so as you can see, I have r squared just in case you're asked about it. Other than that, don't worry about it. These are the 3 things you absolutely need to jot down on your homework or your notes. It's the A, B, and the C. All you need to do to write down the equation of the line of best fit is you're going to substitute negative 0.015 for A. Leave your x and your y alone. And then you're going to do B, 1.55, and then x. And then C is going to be negative 10.9. And you can put plus negative, that's fine. Okay, so this is A, this is B, and this is C. Just make sure that you're paying attention to the signs, okay? Now what I want you to do is just make a little bitty sketch of the data just so we can make sense of it. So this is your miles per hour. So that's how fast you're driving this car. And then over here is miles per gallon. That's your gas mileage, okay? So your graph, if we can go right back over here, see how it kind of hits right here next to the 0, and then it kind of stops at about 94. Okay, so what I'm going to do is go back to the notes, and I'm going to start here, like here. You just need kind of just a really generic version. Now, the question says approximate the best gas mileage. You want the highest miles per gallon possible. So that means that you're looking for that maximum value right here. Since this is an estimate, just go back over to your graph and then click on just kind of what looks like maybe the highest point on your graph. So I'm going to jot that down. It looks like about 51 and about 29. So I'm rounding it to the nearest whole number. So 51.29. So I'm going to write 51.29. But what number they're asking for? So when it says the best gas mileage, it's asking for miles per gallon. So at 51 miles per hour, you are going to get the best gas mileage at 29 miles per gallon. That's it. Now you only have 2 questions for homework. Let's see if you can get those done in class, okay? Let me know if you have any questions. Thanks.